Right, children. So we are going to start this chapter. In this chapter, we are going to learn about preparation of circuits. Do you remember what we learned in the previous chapters, children? We learned why we need electricity in our day-to-day lives, what is the importance of electricity, and we learned different methods of generating electricity as well. Okay? So preparation of circuits. So you all know that we have to make different types of circuits when we engage in different activities. Okay, when we engage in laboratory activities, we have to prepare different types of circuits. So we are going to learn how to make a basic circuit. Okay, so the activity is, let's connect an electric appliance to an electric cell with conductive wires, right? So we are going to learn there are different types of electrical appliances. So one of those appliances is bulb, right? Electric bulb. So we are going to learn how to connect a bulb to a circuit. Okay. So what are the things we need? We need dry cells and we need conductive wires and we need a switch, right? Now this is a switch. I'll show you how to operate this one. And we need a small bulb. Okay. Right, let's write them first. Dry cells. And we need copper wires, right? These are known as connective wires. Connective wire. This is a switch, okay? And small bulb. Okay, children. Dry cells, connective wire, switch and small bulb. So how to do this activity? Let's see. Okay, look at this diagram. You have to prepare the circuit like this. Let's label this one first, children. Whenever there's a diagram, remember we have to label them. These are dry cells, connective wire, bulb and switch. Dry cells, connective wire, bulb and this is the switch. Okay, children. Right. First, draw a rough sketch of each of the above materials. Now here, this is the diagram. Okay. And prepare a suitable circuit with the above objects to light up the bulb. So what we have to do is, we have to connect the dry cells with each other. You have to use a special holder that we can put both the cells together, right? And then you have to the terminals of the cells, you have to connect the connective wires, and to the end of one wire, you have to connect this bulb, and with another piece of wire, you have to connect the switch to the bulb and to the dry cells. Okay, children? And then you all can see now in the lab, I'm going to show you all how to operate this switch, right? You all can see there's a small lever here, right? When the lever is up, so when this lever is up, the circuit will be closed. You will realize when this lever is up, the bulb does not light up. Okay, children? So when you close the switch, when you put this lever down, it will connect. This one will connect with this side like this, and then you will realize the bulb lights up. Okay, children? So then draw the circuit in your book, and can you explain why does the bulb light up? First of all, we'll see this experiment in the lab. Right, children? Now I'm going to show you all how to make a simple circuit. Right, children? Now to make this circuit, we need two dry cells. And to fix those two dry cells, we need a holder like this. Okay? And we need a small electric bulb like this. And then we need a electric switch. Look at this one. This is a switch and we need some wires. Now first of all, I am going to connect these two cells to this holder. So you all can see in this holder there are positive and negative sides, right? So when you fix these cells, you have to fix it properly. You all can see in this cell there's a positive and negative terminal sides present. So you are going to fix this positive side to the positive side of this holder and negative to the negative. Right, children? Okay. Now we are going to connect these cells, bulb and the switch together with the wires. Observe how to do that. Right. Okay, you all can see I made the circuit. This is a very simple circuit. But you all can see at the moment the bulb is not lighting up. The bulb does not illuminate. What is the reason, children? Can you all see the switch? Now you can see this lever-like part of the switch is opened. If I put this down, you can see the bulb illuminates or the bulb lights up. You can see clearly the bulb lights up when I close the switch. Now if I open the switch, what happens? The bulb goes off. Again, if I close the switch, you can see the bulb lights up. What is the reason, children? If I open the switch, then this circuit is not completed. For the electricity to flow through the circuit, it has to be a closed circuit. So using the switch, you can open and close a circuit. Okay, children? So when I put this lever up, we open the circuit. If I put it down like this, we close the circuit. Electricity flows only through a closed circuit. So only if electricity flows through a closed circuit, we can light the bulb like this. Right, children? So you observed what happened. So do you remember what we did? We set the circuit like this. This is a very simple circuit. What happened when we close the switch? When we put the small lever down, which means it is known as closing the switch, right? When the switch is closed, what happens? The bulb lights up. Why is this possible, children? The reason is when you close this switch, this circuit becomes a closed circuit, right? So which means now dry cells generate electricity through the dry cells. This electricity flows through the circuit as a current. Okay, children? So for that one, we have to close the circuit. When you open the circuit, what happens? Because of the opening from here onwards, electric current cannot flow. Therefore, the bulb does not light up. The bulb lights up only if electricity flows through it. Okay, children? So because of the switch, it's very easy to observe that when the circuit becomes a closed circuit is when the switch is closed, or from all the areas, circuit is connected to each other, right? When the circuit is closed, electricity flows through it. When you open the switch, what happens? The circuit becomes an open circuit and at that time, electricity does not flow and bulb will not light up. Okay, children? Let's write this observation. When the switch is closed, the bulb lights up or illuminates. When the switch is closed, the bulb lights up. When the switch is opened, the bulb does not light up. Okay, children? When the switch is closed, the bulb lights up. When the switch is opened, the bulb does not light up. So what is the conclusion? When we close the switch, what happens? As I explained you all earlier, the circuit becomes a closed circuit. So when we close the switch, electricity flows through the circuit. Okay, children? Therefore, the bulb lights up. Let's write down. When we close the switch, an electric current flows through a circuit. Flows through the circuit. Electric current flows through the circuit. Therefore, the bulb lights up. Okay, children? When we close the switch, an electric current flows through the circuit. Therefore, the bulb lights up. Okay, children? So, the observation is when we close the switch, the bulb lights up. When we open the switch, the bulb does not light up. For the bulb to light up, there should be a flow of electricity. So when we close the switch, an electric current flows through the circuit and therefore the bulb lights up. So I hope you understood how a basic circuit functions. Okay, children? Right. So what is an electric circuit then? So we discussed that electric circuit is a certain system that lets electric current to flow through it. Right? So when an electric current flows through the circuit, so if we consider this setup, this is a very basic simple circuit, right? An electric appliance is connected here, it is a bulb, right? So the bulb lights up only if an electric current flows through this setup, this system, right? So this is an example for a basic circuit. So what is a circuit? How to define a circuit then? It's a certain setup or it is a certain system that lets electricity to pass through it. Okay, and at the same time, remember, in order to electricity to pass through the setup, what should happen? The circuit should be a closed circuit. Okay, children, we'll write. What is an electric circuit? A system that allows an electric current. A system that allows an electric current to flow through it. It is called an electric circuit. Okay, children? A system that allows an electric current to flow through it is called an electric circuit. Okay, children? So in this chapter, we are going to learn more about electric circuits, how to connect different appliances to circuits, and important information on circuits. Okay, right. Our next topic is different types of electric appliances. What is the meaning of electric appliances? Different types of instruments that works using electricity, right? And specifically these type of electric appliances are very important to make circuits. Okay, children? So what are these things? Here we can see, now this is known as a dry cell, right? These are connective wires. Dry cell, you all know the dry cell, right? Connective wires also you all know, right? Now we already discussed about the switch as well, right? And this is a bulb. Look at these three instruments, children. Now this is known as an ammeter. This is a milliammeter and this is a galvanometer. They all can be used to measure an electric current, right? So the ammeter is used to measure large electric currents. Milliammeter and galvanometer can be used to measure small electric currents, to identify small electric currents. Okay, children? Now I'll show you these different types of electric appliances in the lab. Right, children? Now I'm going to show you all some electric appliances. Now I already explained you all electric appliances are very important when we make different types of circuits, okay? So look at the table, children. You all can see there are some of these electric appliances we can use in circuits, okay? So these are some cells and batteries. Look at this, there are different types of cells. Dry cells are there, right? This is known as a button cell, right? And this is a type of battery. This is known as the 9-volt battery, right? And we need connective wires. You all know when we make the circuits, different types of appliances should be connected with each other using these type of wires, right? Look at this wire, children. So you all can see this is a copper wire. This brown color wire is the copper wire and it is covered with a rubber cover, right? So you can see this big wire, it has 3 other small wires inside. Okay, so these type of wires you all can see in different types of electric appliances like rice cookers, television. These type of big wires are there. So if you observe the inside of the wire, you will see these type of small wires inside, right? And these are also types of connective wires. So you cannot see this edge like this, it is nicely covered. So when you connect it to the appliance, can you all see the clip-like part? You can open and connect, right? What is this, children? This is a switch. You all can see you can move this lever up and down. So when you connect this type of switch to the circuit, you all have to connect it with these type of wires from one side like this, right? And another wire from the other side. And then when you connect this switch, if you lift this part up, this is known as opening the switch. And if you connect it like this is known as closing the switch. Now in the other experiments, I am going to show you all how to make a circuit using these type of switches, okay? And look at this one, these are different types of bulbs. Look at this. This is a filament bulb. These are known as LED bulbs. Right, children? And what is this? Now these are other electric appliances. This is a milliammeter. This is a galvanometer. This is an ammeter. So all these 3 appliances are used to measure the electric currents flowing through a circuit. Now when you consider this ammeter is used to measure larger electric currents. Galvanometer and milliammeter can be used to measure smaller electric currents. Okay, children? So in the other experiments, we are going to see how to connect these type of electric appliances and how to make circuits. Right, children? So after discussing it in the lab and after observing these appliances in the lab, I hope it is very clear. We will write the names of them. This is dry cell. There are different types of cells. Connective wire. wire. This is a switch. This is a bulb. Ammeter. Milliammeter. And galvanometer. We already discussed about the galvanometer, right? Center zero galvanometers. There we use galvanometers in different experiments as well. Okay? So in the upper grades, you are going to learn about more electric appliances, but these are the appliances we are going to use for the experiments in this grade. Okay, children? We'll move on to the next. Using symbols for electric appliances in circuits. So what is the meaning of symbols, children? Now, go back to the previous experiment again, children. Now, do you remember this is a small circuit? So, you are supposed to draw this circuit here, then draw the circuit in your book. You are supposed to draw this circuit, copy it as it is. Okay, children? So, you can draw, when you draw the dry cells, look at these things. This is how you have to draw, right? And the bulb and the switch, right? You have to draw in a certain way. Okay? But it's difficult to draw and it takes a longer time, right? So when you draw the bulb, you have to show that how the filament is present, the shape and everything properly, right? Switch is also the same. So it takes a longer time to draw the real pictures in the circuits, okay? So to make the things easier, to draw the circuit diagrams easily, we use special symbols for different types of electric appliances. Okay, so when we use these types of symbols, it's very easy to draw circuits using these type of circuit symbols, right? So using symbols for electric appliances in circuits, okay? Let's see, appliance wire or connective wire, right? So connect different types of appliances, different components in circuits with one another, we use wires, right? So appliance wire, to use is to conduct electricity. What is the symbol that we can use? That is the easiest. We use a line, a straight line, right? So this is for wires. The next one, switch. Switch is used to break the connection when necessary. Now, why do we connect a switch to the circuit? Let's say that in the previous experiment, when we don't want to turn on the light, we can open the switch, right? So if we connect a switch, when the switch is open, circuit will not work. So if we want to stop working the circuit, we can easily add a switch, okay? So to break the connection when necessary, what is the symbol? Observe carefully. So you can draw the switch like this. Right. Okay, children? So this is the switch. This is an open switch. So if you want to draw a closed switch, how would you do that, children? Right. So if you want to draw a closed switch, this is how you do that. You have to do the same thing. So this is a closed switch. Okay, this is an open switch. Okay. So the next one, bulb. So why do we use a bulb? We connect at different instances. We connect bulb in circuits. Okay, to get light, to identify the presence of electricity, we use bulbs. To indicate that electricity is flowing through a circuit also, we can add bulbs. Okay. So what is the bulb? How to draw the circuit symbol of a bulb? So you have to draw a circle like this first. Then you have to put a cross inside the circle and show that like this. Okay? So a bulb with a cross like this and two lines. Okay, children? So ammeter or milliammeter? Ammeter and milliammeter used to measure current, right? Milliammeters used to measure small electric currents. Okay? How to draw this one? To measure the current, ammeter and milliammeter. How to draw the ammeter? That's also easy, right? We have to draw a circle like this and we have to write capital A inside. And then you have to draw two lines like this. Okay? So how to draw a milliammeter? Milliammeter is the same thing. But instead of capital A, we write M and A both. It's also very easy. You draw a circle. You have to write simple M and capital A like this. Okay? Simple A, milliammeter. And then draw two lines like this. Okay, children? Then galvanometer. So you can understand how it goes. Galvanometer. How to draw the galvanometer? Again, it's very easy. You draw a circle like this and then we have to write capital G and then draw two lines. Okay? And finally, electric cells to supply electricity. Electric cells are used to supply electricity. Okay? How to draw the electric cells? Again, you have to draw a long line and parallel to that a shorter line like this. Okay? And then two lines from here like this. Okay, children? So you all know when we consider electric cells, now this is example for dry cell, right? When you consider electric cells, there are two terminals. What are they? Positive and negative terminals. Now here, what is the positive terminal, children? This long line indicates the positive terminal. The short line indicates the negative terminal. Look how easy to draw the circuit symbols other than using the real pictures, children, right? So let's say that if you have to draw a circuit using a few of these electric appliances, what will happen? It will take a longer time and it's a little difficult to draw. Okay? But these type of symbols very easy to draw because some circles and lines you have to use. Right, children? So it saves your time and it saves your energy as well. Okay? So these type of symbols that we drew here are known as circuit symbols. Okay, children? Right. Drawing a circuit using the standard symbols. Now let's practice how to draw different circuits using the standard symbols or circuit symbols that we learned just now, right? So look at this circuit. This is the same circuit that we used in the previous activity, right? So how to draw this circuit using the standard symbols, children? Let's do that now. So here we have two dry cells. You can see two dry cells. Let's draw now. You all know to draw the dry cells, you draw one long line and one short line like this. There are two dry cells, now therefore I'll draw another dry cell here using the symbols. Long line, short line. And you have to connect them like this. And we have to connect a switch. This is the switch. going to draw another line like this, and then we have to draw the bulb. When you draw the bulb, a circle and a cross inside like this. Okay, children? So there are two dry cells. This is the positive terminal, negative terminal, right? And there's a switch and there's a bulb. See how easy to draw the same circuit with circuit symbols, children. What will happen if you draw it in this way? It will take a longer time and it's very difficult to draw, right? So here by using circuit symbols, it's way easier to draw the circuit, okay? Right. Let's draw another one as well. So this is the circuit diagram of this circuit, right? Let's see that we'll draw another circuit. We'll connect 4 dry cells and a galvanometer and a switch, a bulb as well, right? We can draw different types of circuits. We'll draw 4 dry cells. Right. Okay. So you have to connect them each other like this. And then we'll connect a galvanometer here. So you all know galvanometer, circle, and inside the circle, capital G, right? So let's connect a switch and a bulb as well. This is the switch and this is the bulb. Okay? So this is another circuit diagram. The galvanometer, 4 dry cells, a switch and a bulb. Okay, children? So I hope it's very clear. By using these type of circuit symbols, it's very easy to draw the circuits. Okay, children? Let's move on to the next. Okay, we have an activity to do, preparing circuits. Now we know how to prepare basic circuits, and at the same time we learn how to draw circuit diagrams using circuit symbols, okay? So this activity we are going to learn how to connect bulbs in different ways. There we are going to learn that we can connect bulbs to a circuit in 2 different ways, okay? So what are the things we need to do this activity? Let's write. We need dry cells, connective wire, we need a switch, and we need 2 bulbs. Okay? So what do we have to do? Let's see. The method. Look at this one. We have to prepare 2 different types of circuits like this. We'll name them. This is A. This is B. Right? Prepare circuits in different ways to light up the 2 bulbs at the same time. So first we are going to prepare this circuit in the lab. We are going to check what would be the brightness of the bulb would be like. And then we are going to change this circuit into this, right? The second circuit we are going to prepare like this. You all can see the way that we connect the bulbs are 2 different ways, right? And then in second instance, we are going to check what happens to the brightness of the bulb, right? Brightness of the 2 bulbs. Okay, so when you look at these 2 diagrams, these parts are the same. But look at in A diagram, how the bulbs are connected. You can see the bulbs are connected in the same line, right? The bulbs are in the same line. This type of connection is known as a series connection, children. In the upper grades, you are going to learn more about these type of connections, okay? So if these type of components are connected in the same line, these type of connections are known as a series connection, right? Look at this one. This bottom part is the same, but when you consider the two bulbs, you can see this wire from this part divides into two parts and each part contains a bulb. From here again the two parts connect with each other and it connects to the cell, right? So here by looking at this diagram, it's very clear these two bulbs are parallel to each other. So if we connect bulbs in this way, this type of connection is known as a parallel connection. Right, children? If we connect the bulbs in the same line, that is known as a series connection. And if the bulbs are parallel to each other, that type of connection is known as a parallel connection. Okay? So prepare circuits in different ways to light up the two bulbs at the same time. Draw each circuit using the standard symbols. Now we can do that, right? Check the brightness of the bulb that's same at each time. In the first instance, what happens to the brightness? And here, what happens to the brightness and what are the differences between the brightnesses, right? First, the brightness of the bulb similar at each time. So we have to do this activity, but before that, we will draw the circuit diagrams for these two circuits, okay? Now you all can do this with me, children, right? So at this point, you all can stop the video and you can draw the circuit diagrams for these two circuits and check whether you have done correctly when I explain, okay? Right. Let's see, there are two bulbs in the same line. There are two bulbs in the same line, like this. And we have to connect them like this. There's a switch, and according to this one dry cell. Long line, short line. Okay. Right? Two bulbs in the same line with connective wires, one dry cell and a switch. Okay? What about B? Let's draw B as well. We all know the bulbs are parallel to each other. The two bulbs are parallel to each other. Okay? Other parts are the same as A. Right. Okay, children? So diagram A, two bulbs in the same line. This type of connection is known as series connection, right? One dry cell and the switch. Okay? Here, two bulbs are connected parallel to each other. This type of connection is known as the parallel connection, right? So parallel to each other, and at one point they both combine into one line and connect to this switch and the dry cell. Okay, children? So according to this one, we have to draw each circuit using the standard symbols, so circuit symbols. Now we are going to do this activity in the lab. Right, children? Now we are going to prepare different types of circuits using two bulbs. So for this one, we need a battery like this, and we need two bulbs, a switch and connective wires. So first of all, I am going to make a circuit by connecting these bulbs in the same line. Two bulbs I am going to connect in the same line. We'll prepare that one now. Now you already know how to connect these circuits because we already made a simple circuit, right? Okay. Right. So we made the circuit. You can see this is the circuit. Right? So you all can see that I have connected these two bulbs in the same line. Okay, children? Now I'll close the switch. Right. You can see both the bulbs light up. Right, children? Look at the brightness. Okay. Now we are going to make the second circuit using the same bulbs, but this time we are going to connect the bulbs parallel to each other. So in the first circuit, we connected the bulbs in the same line, but this time, the second instance, we are going to connect these two bulbs parallel to each other. Okay? Look how I'm going to do that. I'm going to do a small change here. I'm going to connect another wire like this. Right. You all can see I have connected the two bulbs like this. So I am going to connect these other wires in the middle of these wires. You all can see there's a small opening. I am going to connect this wire to those openings. Even from this side, I am going to do the same. Right. Now we have completed the second circuit as well, children. Look at the circuit now. Now look how I show you the circuit. This is our circuit. Now can you see, when you look at the two bulbs, you can clearly see that the two bulbs are parallel to each other, children. Now earlier in the first instance, we connected both the bulbs in the same line. This time, the two bulbs are parallel to each other. Now we will close the circuit using the switch. What can you see, children? You can see the two bulbs light up. This time, the brightness is a little higher. Okay, children? So earlier, when the bulbs were in the same line, the brightness was different than this. Okay, children? So after doing this activity, it's very clear that when you have several bulbs, there are different ways to connect these bulbs. You can connect either in the same line, right? All the bulbs you can connect in the same line, or you can connect these bulbs parallel to each other as well. Right, children? So you observed the experiment when I was explaining. Do you remember what happened, children? So in the first instance, we connected the circuit like this. Two bulbs are in the same line, or the series method. Here, the two bulbs are parallel to each other. Do you remember what happened to the brightness of the bulb, children? I hope it was very clear. When we connected the bulbs like this, which means parallel to each other, the brightness is higher. Okay, the brightness increased when we connected the bulbs like this. Right, children? So here also there was a brightness, certain brightness, but when we changed this setup into this setup, the brightness was increased, okay? We'll write down that one. Observations. When the bulbs are connected in the same line, which means in series. We'll write within brackets, in series. Brightness of the bulbs is less. When the bulbs are connected in the same line or in series, the brightness of the bulbs is less. Next one. When the bulbs are connected, parallel to each other, the brightness increases. The brightness increases. Okay, children? When the bulbs are connected in the same line or in series, the brightness of the bulbs is less, right? When the bulbs are connected parallel to each other, the brightness increases. So there are different ways of connecting different appliances like bulbs to the circuit. So based on our necessity, we can connect them in different ways. So I hope this part is very clear now, okay? So here we have the terminals of cells and batteries are named as positive and negative, right? You all are very familiar with dry cells now. When we learn about the dry cells, we learn that there are two terminals, positive and negative terminals, right? A current always flows from the positive terminal to the negative terminal, right? It's very important to memorize this part, children. A current, electric current, always flows from the positive terminal to the negative terminal, right? So we will consider a simple circuit. Now if this is a dry cell, and connected to a very basic circuit with one bulb, right? This is the bulb. So if this is the circuit, you all know now the long line indicates the positive terminal and short line of the cell indicates the negative terminal. Okay? So a current always flows from the positive terminal to the negative terminal, and this happens through the circuit. Right? Now this is a closed circuit. Okay? So what happens from positive to negative terminal? Electricity flows. From positive terminal, it goes out like this. It flows through the circuit. It goes through the bulb. When electric current goes through the bulb, it lights up, right? And from this side, it comes back to the cell, right? So from positive terminals of the cell to the negative terminal of the cell, through the circuit, electricity flows. This is very, very important, right? Or current always flows from the positive terminal to the negative terminal. So when fixing an ammeter to a circuit, remember, like when we consider ammeters, galvanometers, milliammeters, they also have a positive and negative terminal, right? So through them also electricity flows to a certain direction, right children? So therefore, when fixing an ammeter to a circuit, the positive terminal of the ammeter should be fixed to the positive terminal of the battery. This is very important, right? Positive terminal of the ammeter should be connected to the positive terminal of the battery. Okay, so what happens? So let's say that we have a dry cell like this, right? If you want to make a circuit using an ammeter, connecting an ammeter to the dry cell with wire, how do you have to do? You have to connect the positive terminals of these appliances. Ammeter, how do you draw children? A circle and capital A. Okay? So this is the positive terminal of the cell. This is the negative terminal of the cell. Ammeter also has positive and negative terminals. Therefore, positive terminal of the ammeter should be connected to the positive terminal of the cell. So this is the positive terminal of the ammeter. It should be connected to the positive terminal of the cell. Okay? Positive and positive, negative and negative. Okay children? When fixing an ammeter to a circuit, the positive terminal of the ammeter should be fixed to the positive terminal of the battery or a cell. Right children? We have to be careful when we make different types of circuits. We have to be careful of these type of small information. Okay children? We'll move on to the next. Okay, we have an activity to do. Identify the symbols in the circuit. What are these symbols children? You all know this is a switch. This is the dry cell. This is the bulb and the ammeter, right? And these are conductive wire. Okay? Identify the symbols in the circuit. Find the necessary appliances and construct the given circuit. Draw the way that you can see the circuit in your book and record 2 observations that you can see when the switch is on. Right children? So first of all, you have to prepare the circuit like this and you have to close the switch. When you close the switch, you have to observe what happens. Now we are going to do this small activity in the lab. Right children? Now we are going to make another circuit using an ammeter. Now you all know ammeter is an instrument that is used to measure an electric current. Okay? So this is the ammeter. You all can see there's this indicator. At the moment, the indicator is at 0. So the indicator moves and this is known as the deflection of the indicator. The indicator deflects or moves only when electricity flows through a circuit. Understand children? And also you know that electric current flows from positive terminal to the negative terminal of the circuit, and therefore when you connect a battery or a cell to an ammeter, you have to connect the terminals properly, which means when you connect the battery or a cell to an ammeter, you always have to connect the positive terminal of the cell or a battery to the positive terminal of the ammeter. Can you all see the positive and negative terminals of the ammeter children? Look carefully. You all can see the positive and negative terminals of the ammeter. So you have to make sure that when you connect the cell or a battery to the ammeter, the positive side should be connected together and the negative side should be connected together, right? Okay. Now we will make the circuit children. Now first of all, I am going to take the battery. This is a small battery. You all can see this is the positive terminal and this side is the negative terminal. So I will take the red wire to connect the positive terminals. So I am going to connect this positive terminal of the battery to the positive terminal of the ammeter. Right. And and I am going to take this wire, connect in like this, and the other end I am going to connect to this switch. Right. So the other side of the switch I am connecting like this to the bulb. So the other end of the bulb I am going to connect to the ammeter like this. Right. Now can you all see the circuit, children? You all can see the positive terminal of the battery is connected to the positive terminal of the ammeter, and the negative terminal taken from this side is connected to the negative terminal of the ammeter. Understand, children? Right. Now, can you see the ammeters working? You can see still, even though we already made the circuit, you all can see the bulb is not lighting up, and at the same time ammeter indicator is also not deflecting. It is still at 0, which means electricity does not flow through this circuit yet. So what do we have to do? We have to close the circuit, because you can see the switch is still opened, right? So I am going to close the switch. What can you see, children? The bulb instantly lights up, and can you see where the indicator is now? So when I open the switch again, you can see the indicator goes back to 0, and you can see the indicator moves towards these numbers when I close the switch, right? Which means indicator moves because electricity flows through the circuit. So when we close the switch, what happens? Electricity flows through this circuit. So according to the amount of the electric current, this indicator moves. Okay, children? So what are the observations you can see when I close the circuit? There are 2 observations. When I close the circuit, the bulb lights up and the ammeter indicator moves. Right, children? So you observed what happened. Now you all are very familiar with these type of small circuits and what happens when we switch on the circuit, okay? So what happened when we turn on the switch? As I told you all, electricity flows through this circuit, and therefore we can say the indicator of the ammeter deflects, and what happens to the bulb? The bulb lights up, okay? So both the observations indicate that an electric current flows through the circuit. That is because the indicator of the ammeter deflects only when an electric current passes through it, okay? And the bulb also lights up only when an electric current passes through it, okay, children? So what are the observations here? You have to record 2 observations that you can see when the switch is on. Let's write the observations. Right. Observations. Observations, 2 observations. Number 1, the bulb lights up. The bulb lights up. And number 2, what happens, children? The ammeter indicator deflects. The indicator of the ammeter deflects. Okay? The bulb lights up, the indicator of the ammeter deflects. Okay, children? We'll move on to the next. For your extra knowledge part, even though these are extra knowledge, for your extra knowledge, they are equally important, okay, children? Right. Ammeter shows the amount of current that flows through the circuit. We already know this, right? We learned that ammeter, galvanometer, milliampere, they indicate the flow of electricity, and you can measure the electric current using these type of instruments, okay? So the importance of ammeter, right? It shows the amount of current that flows through the circuit. Ampere is the unit used to measure the amount of current, right? The value or the amount of current is measured in amperes. Symbols of amperes is capital A, children, right? Unit used to measure the current is, let's write again. The unit used to measure the amount of current. Amount of current is amperes. Ampere. And the symbol is capital A. You are going to learn more about these things in the upper grades, okay? So ampere is the unit used to measure the amount of current. To get an accurate measurement, you have to connect the positive and negative terminals of the ammeter or milliammeter correctly. What do you mean by correctly, children? You all know that you have to connect the positive terminal of the ammeter to the positive terminal of the cells and the negative terminals of the ammeter to the negative terminals of the cells. Okay, children? So then you can measure the amount of current correctly. Understand, children? We'll move on to the next. Now we are going to learn a new topic, conductors and insulators. Right, children? The activity is identifying conductors and insulators. Now, so far we learned about different types of circuits, how to prepare circuits, and now we know that circuits, when the circuit is a closed circuit, electricity flows through the circuit. Can we use just any material to make circuits, children? After doing this activity, you will understand what is the meaning of conductors and insulators. Okay? Right. So, what are the materials we need? We need a lot of materials to do this activity. Right? We'll write them. We need dry cells. Right? We need a dry cell and connective wire. Connective wire, a small bulb, right? And then we need the outer casing of a wire, right? Do you remember when I was showing you all these electrical appliances, I showed you different types of wire, connective wire, okay, with different colors and all, right? So actually those wires are covered with a rubber cover, right? You all know the wires are of different colors, blue, red, green wires are there, right? So the colorful part is actually known as the casing, right, children? So we need an outer casing of a wire. Outer casing of a wire. And then we need to use the inner part, right? So inside this, covered with this outer casing, inside the wire is there. So normally when we connect these wires to the circuit, we have to connect it from this inner part, or this is known as the core of the wire, right? So core of a wire. Core of a wire we need, okay? Then we need a coin. Then we need a piece of dry paper. Dry paper. And then we need that metallic wrapping of a chocolate, right? You all know that chocolate comes in a metallic wrapped in metallic paper, right? We need a piece of that as well. Chocolate wrapping. Chocolate wrapping. And then we need a carbon rod, right? So you can find a carbon rod from a used dry cell, right? If you carefully cut open a used dry cell, you can find a carbon rod inside. But remember, don't do this alone, right? Because dry cells contain a lot of chemical substances, you have to get the help of an adult. And at the same time, when you cut open this dry cell in order to get this carbon rod inside, you have to wear gloves. Okay, right. You need a carbon rod. Okay, and then we need a dry piece of wood. Let's write wood or dry wood. Okay, and then we need a pencil rod, right? You all know that when you sharpen the pencil, you can inside the pencil, the wooden part, there's a graphite rod. We need that type of graphite rod. Okay, pencil rod. Pencil rod. And then we need a piece of plastic and a piece of polythene. Plastic and polythene. Now you must be wondering, what are we going to do with all these lot of materials? Let's see how to do this activity. Right, look at this one method. Look at the diagram. You have to prepare the circuit like this. Let's label this. Dry cells, connective wire and bulb. Dry cells, connective wire, and a bulb. So you have to prepare the circuit like this. Prepare the circuit as shown in the figure, but you all can see there's a gap at this A and B, right? This is not connected. You all can see very clearly. This circuit is an open circuit. What is an open circuit? When the circuit is not completed, that is known as an open circuit. Or like, let's say that if there's a switch here and when the switch is opened, right? So at this moment, you all know that electricity does not flow through the circuit because this is not completed. Right, children? So this part, there's a gap here between A and B. Then connect the materials given in the below table. Now we already discussed about this lot of materials here. What you have to do is, you have to take each of those materials and you have to place them in between this A and B edges, right? So you have to place them in this gap as you connect A and B, right? So then connect the materials given in the below table between. The table is also given here, right? And below table between the terminals A and B. So when you place the materials, you have to check whether the bulb lights up. So actually when you place the material, this open circuit will become a closed circuit. So when you close the circuit with each of the materials given in the list, you have to check whether the bulb lights up. Okay, children? So check whether the bulb lights up, tabulate your observations. So we'll do this activity in the lab now. Right, children, now we are going to see how electricity conducts or go through different materials. So to do this activity, as I explained you all, we need different materials, okay? So we have a piece of wire, you all can see, and a coin, and a piece of dry paper. And this is the silver color paper that we use to wrap these chocolate slabs, okay? And this is a carbon rod, a piece of wood, and you all can see that this is the inner part of the pencil, okay? This is actually made of a substance called graphite, okay? And we need a piece of plastic and a piece of polythene, right, children? And then we have to make the circuit like this. Now you already know how to make different types of circuits. Can you all see? Now I have made the circuit like this. Observe carefully. So I have connected these wires to this battery and another wire from this side connected to this bulb. And another wire is connected to the other terminal of the bulb, and these two terminals are opened. You all know that for this electricity to travel through a circuit, it should be closed. Now see, when I close these two, connect these two wires, the bulb lights up. Now it won't. That is because these two ends are opened, okay? Right. Now I am going to connect these two wires to each of these materials. I am going to place each of these materials in between these space. Okay, and we'll see what happens, whether the bulb lights up or not. Right, children. First I am going to start with this wire. You all can see this wire. This is a copper wire. There's an outer casing. This blue color part is the cover of this copper wire. It is actually made up of rubber. Okay. First of all, I am going to connect these two terminals to the outer casing. What happens, children? The bulb does not light up. Okay. Now we are going to connect these two terminals to the copper wire. I mean the inner part of the wire. See, now what happens? The bulb lights up. Even if I connect it to this part, it still lights up. Okay, right. Right. I'm going to keep these two terminals to this coin now. What happens, children? The bulb lights up. So the bulb lights up only if electricity passes through this material. Now earlier, you all saw that when I kept these two terminals, as they touch this outer part, the bulb did not light up. Why? What is the reason? That is because through this outer part, electricity does not travel. But when we consider the inner part or the copper wire, the bulb lights up. That is because through the copper wire, electricity travels, so conducts, okay? Even through the coil, the electricity conducts. You can see very clearly the bulb lights up. Right. We'll take this piece of paper. It's a dry paper. Can you see the bulb does not light up? Okay. Right. So I'm going to separate the things where the bulb lights up, materials in one place, the other materials separately. Okay. And I'm going to connect these two terminals to the shiny paper. What happens, children? Now again the bulb lights up, which means through this shiny paper also electricity conducts, right? Now I'm going to take this carbon rod from a dry cell and I'm going to place it like this. What happens? The bulb illuminates or lights up, right? So which means through the carbon rod also electricity conducts. And I'm going to take this piece of wood. The bulb does not light up, which means the electricity does not pass through this wood. Now I'm going to check with the rod of this pencil, the inner part of the pencil. See. Again, the bulb lights up. So which means this also goes to this side. And the piece of plastic, this time bulb does not light up, which means electricity does not pass through the plastic. And finally, the piece of polythene. Right. Again, bulb does not light up, which means electricity does not pass through this material as well. So it's very clear after doing this activity, some materials conduct electricity and some materials do not conduct electricity. Conducting electricity means passing electricity through certain materials, okay? So it's very clear some of these materials conduct electricity and some of the other materials do not conduct electricity. I hope this experiment is very clear now. Right, children. So the activity was very clear. I hope you all enjoyed the activity. So do you remember the observations, children? Let's see. So this was the circuit we prepared and we had to place different materials that was given in the list in between A and B. And when we placed some materials, it was very clear the bulb lights up. when we place some other materials, the bulb does not light up, okay? So we have to mention those observations here. So the materials given here, whether the bulb lights up or does not light up. So I'm going to put a tick. If the bulb lights up, I'm going to put a tick. If the bulb does not light up, I'm going to put a cross, okay? So outer casing of the wire. First of all, before I write this one, I will mention that. Right? Tick, bulb lights up. Cross, bulb doesn't light up. Does not light up. Okay? So outer casing of the wire, what happened, children? The outer casing of the wire, when we place that outer casing, the bulb did not light up, right? It does not. And wire in the core of the wire, what happened when we put that copper wire? The bulb lights up, okay? Coin, what happened? Coin, bulb again lights up. Dry paper, bulb did not light up. And shiny wrapping of a slab of chocolate, the bulb lights up, right? Carbon rod of a dry cell, the dry cell has the carbon rod inside. I explained you all how to take it out, right? So there the bulb lights up, right? Dry wooden logs, no, right? With the dry piece of wood, the bulb did not light up, right? Rod of a pencil, when we use the graphite rod or the pencil rod, the bulb lights up, right? And plastic and polythene board, bulb did not light up, okay? Right? So, outer casing of the wire, dry paper, dry wooden logs, plastic and polythene, when we use those things in between the gap, the bulb did not light up. But when we use the wire in the core of the wire, the coin, shiny wrapping of a slab of chocolate, the carbon rod and the pencil rod, what happened? The bulb lights up. So it's very clear after doing this activity, when we use different materials, only with some materials the bulb lights up. So what is the conclusion, children? Why does this happen? So you all know, for the bulb to light up, there should be an electric current that should pass through it. Okay, only if electricity passes through that one, the bulb lights up, right? So what happens when we connect? Now you all know that when we consider all these three things given, the bulb, connective wire and dry cells, through them of course electricity passes, right? But here it depends on the material that you place in this gap, okay? So through some materials electricity does not pass. So electricity does not pass through some materials means if we connect those type of materials in the gap, the bulb will not light up, right? And at the same time, when we were going through the observations, it was very clear with some materials the bulb lights up. So those are the materials where the electricity passes through. Okay, children? So after doing this activity, it's very clear only through some materials electricity passes. Okay? Right. Let's write conclusion. Electricity passes or flows through. Some materials. Right? Electricity flows through some materials and electricity does not flow through some other materials. Some other materials. Okay? Electricity flows through some materials and electricity does not flow through some other materials. So you can even write electricity flows through only some materials. Okay, children, which means it is selective, right? Okay, we'll move on to the next. So the bulb lights up only when electricity flows through the circuit, right? For the bulb to light up, the necessary factor is the flow of electric current, okay? So you can divide the materials used in the above activity into two categories. Okay, children. So what are the two categories? It's very clear when we use some materials, the bulb does not light up, which means those materials do not carry electric current. Okay, so only some materials carry electric current. Okay, let's write. Okay, so what are the two categories? The materials which carry electricity. Right? That is number one. Number two, the materials which do not carry electricity. Okay. So what are the two main categories that we can divide those materials after doing the experiment? The materials which carry electricity and the materials which don't carry electricity. Okay. We'll move on to the next. We have this assignment to do. Divide the materials in the table of activity into two categories as above. So what we have to do is, we use this set of materials in the activity. We have to divide these materials into these two groups. The materials which carry electricity and the materials which do not carry electricity. Right now it's very easy to do. We'll do that. Right, we have to do it using a table. So you all can do this before me, children. Okay, as we have already discussed what is the reason here. You all have the knowledge to do this activity by yourselves now, right? So before you watch this one, you all can stop the video and do it by yourselves, and then you can watch this, okay? Right. So what are the two groups we have to use? Materials which carry electricity, materials which do not carry electricity, right? Materials which carry electricity. Materials which do not carry electricity. Okay, right. What you have to do is, you have to categorize the materials we used in the experiment. Now, how to decide whether these materials carry electricity or not? It's very easy. If the bulb lights up with certain materials, that happens because electricity passes through those materials, right? If electricity does not pass through some materials, those type of materials cannot make the bulb light up. Okay, children, which means all these materials, the wire in the core of wire, the coin, shiny wrapping paper, carbon rod and rod of pencil. When we use those 5 different types of materials, the bulb lights up, which means these materials carry electricity, right? And the other 5 materials given here, outer casing of the wire, dry paper, dry woods, and plastic and polythene, they don't carry electricity. That is why when we connect it to the circuit, to the gap of the circuit, the bulb does not light up. Okay? If they carry electricity, the bulb would have lighted up, but it does not happen. That is because these materials don't carry electricity. Okay? It's easy to divide now. We'll do that. We'll write in short forms. So outer casing of the wire goes to the materials that don't carry electricity. Right? Outer casing of wire. Right? The core of the wire, materials which carry electricity. Core of the wire. Okay? What else, children? When we consider coin that carries electricity, shiny wrapping carries electricity, carbon rod carries electricity. We'll write coin, chocolate wrapping, chocolate wrap, carbon rod, and finally pencil rod. Pencil rod also. All these things carry electricity. Okay? What about the materials which do not carry electricity? Outer casing of wire. What are the other things, children? Let's write. We can write dry paper, right? Dry wood, plastic, polythene. Let's write them as well. Dry paper, dry wood, polythene, and plastic. Right? So the materials which carry electricity, core of the wire, coin, chocolate wrapping, carbon rod and pencil rod. Okay? Materials which do not carry electricity, outer casing of the wire, dry paper, dry wood, polythene, plastic. Okay, children? We'll move on to the next. Materials that conduct electricity. Now, can we give a special name to the materials that carry electricity and the materials that do not carry electricity? Look at this. Materials that conduct electricity. Conduct means carry, the pass through, right? The materials that conduct electricity or that carry electricity are known as conductors. Okay? Materials that do not conduct electricity, which means this one. The materials that do not conduct or do not carry electricity are known as, what is the name given, children? Insulators. Okay, children. So the materials that conduct electricity are known as conductors. Materials that do not conduct electricity are known as insulators. So in our day-to-day life, we use a lot of conductors and insulators, children. Right? Based on our necessity, sometimes we have to use conductors, specifically when we use electrical appliances, when we prepare electric circuits, we have to use the materials that conduct electricity, right? Which means we have to use conductors. And other times, let's say that the handles or the lids of the electric cookers, right? So when we handle these different types of electrical appliances, they should be user-friendly and they should be very safe to use, okay? So in that case, when we touch these different appliances, the handles and all, they should contain insulators. What will happen if the handles and all the other parts that we hold them or carry them with also contains conductors? Whenever we run the machine, we will get electrocuted. Okay, so that's why I told you all conductors and insulators all are very important and we use them in our day-to-day lives. So what are the good examples for these conductors and insulators, children, right? Some examples for good conductors. So most of the metals are very good conductors, children. We'll write some of them. So most of the time to make different circuits, right, as connective wire, we use copper and even aluminium, okay? We'll write some examples. Copper, aluminium, right? Silver is a good conductor, right? Iron, steel, right? They all are good conductors, children. Some examples of good insulators. Insulators means the materials that do not carry electricity, okay? What are the examples? We'll write now in the list also. We wrote some of them: plastic, wood, polythene, right? What else, children? Now here we can write carbon. Now remember, you are going to learn later, most of the metals conduct electricity, but carbon is coming under non-metal. Carbon is not a metal, but at the same time it conducts electricity very well, right? So most of the metals and some non-metals also conduct electricity, okay? So here what are the examples? Some examples of good insulators. We'll write plastic, right? Paper, wood, mica. Mica is used in a lot of electronic appliances to make the circuit board. Mica is used, okay? Right, mica is a material that do not conduct electricity, right? And there's another material called ebonite. Glass also does not conduct electricity, right? There are many other materials that we can write. You can find more examples, more information on what are the conductors and what are the insulators, and you can write a longer list for this one, okay? Right. So examples for conductors: copper, aluminium, silver, iron, steel, carbon. And examples for insulators: plastic, paper, wood, mica, ebonite, glass, clothes, okay? They don't conduct electricity. Okay, children? Right. So look at this one. Another additional knowledge part is given. Mercury, which is a metal in liquid. Now, have you seen mercury? Some of you must have seen them in thermometers. There are different types of thermometers. Some of these thermometers are known as bulb thermometers. Nowadays, we use most of the time, nowadays we use digital thermometers. But bulb thermometers are also there, right? The bulb thermometer has a glass bulb filled with mercury, okay? So mercury is a liquid, at the same time it's a metal, right? Mercury, which is a metal in liquid state, okay? It is a good conductor. Do you remember I told you most of the metals are good conductors, okay? So mercury is also a very good conductor, but it is in liquid state, okay? Salt, water, lime juice are also conductive liquids, which means they conduct electricity. Okay, children? But electricity does not flow through kerosene, oil and petrol. Now, these are very important for your general knowledge. Okay, children? Even though salt, water, lime juice, they conduct electricity, kerosene and petrol, they don't conduct electricity. Okay? As there is salt mixed in drinking water, electricity conducts slightly through water. What about water? Now you all know that drinking water contains a lot of minerals dissolved in it, right? Therefore it conducts electricity, right, children? At the same time, if you consider pure water, remember, children, pure water does not conduct electricity, right? However, drinking water has a lot of substances dissolved in it, even though we can't see it, a lot of minerals dissolved in it. Therefore, because of the presence of minerals, it can conduct electricity. Right, children? This is why you have to, when you handle these different types of electrical appliances, you have to be very careful. Your hand should be dry, it should not wet, right? Because water, like drinking water, can conduct electricity. Okay, you will get electrocuted otherwise. If there's a leak, you will get electrocuted. That's why you have to be very careful when you handle most of these electrical appliances. Understand, children? So we have completed this chapter, children. Do you remember what we learned in this chapter? We learned how to prepare circuits and we learned about circuit symbols. Now we know that using circuit symbols, we can draw circuits very easily. And at the same time, we learn what are the conductors and insulators as well, along with examples. Okay, now we are going to start the next chapter.